We are still factoring or factorizing expressions, which we have learned now is putting it in the brackets, yeah? So it's the opposite of expanding, which is getting rid of those brackets. And in my previous videos, and it's important that you've seen those as well, we have spoken about the questions you should be asking yourself, yeah? So the first question you always ask yourself is there a common factor, yeah? The second question you always ask yourself is, can I factorize it by grouping? And the third question, and that's what we're going to be doing now, is the question, is it normal factoring? And I call it normal factoring, which is not an official term. But why do I call it normal factoring? Because it is the one that occurs most frequently, all right? And it has the format of, for instance, x squared plus 7x plus 12, yeah? And we will solve this one together at the end of this video, and you will notice that it is fun to do this one, okay? So, normal factoring, yes, let's go. Teachers have all, different ways to explain this to you, and I have my way, and so there we go. First of all, let me just expand. Remember this one. Let's say x plus 2 and x, what shall we do, plus, well, don't do plus 3, let's do plus 4, okay? And the question would be expand it, yeah? So let's expand it. X times x, so this is the FOIL method, remember that one? X times x is x squared, x times 4, 4x, next one, 2 times x, 2x and 2 times 4, which is 8. And then you would simplify it, and you'd get x squared, you have those two like terms there in the middle, plus 6x, so you add them, and then you have plus 8 at the end. Alright, fantastic. That is something you already know, so that doesn't trouble you. But now we are factoring, and they'll ask you, factorize the expression x squared plus 6x plus 8. And as you can see, that was your answer to this question when you had to expand. Okay. Now, I should go now from here to there. And how do I do that? Now, I always tell my students, guys, this is a puzzle. Yeah? You should be enjoying this. Yeah? When I was like 10 years old, we go on holiday with my parents to France, sit in the car for hours and hours and hours, and we'd have a book with puzzles. Yeah? And this is one of those puzzles. This is fun because you already know, because it's normal factoring, that you will have to put those two sets of brackets there, yeah, because we are trying to find that one. And then you should ask yourself the question, I am looking for two numbers, yeah, two numbers, yeah, that number and that number. If I multiply those numbers, I should get 8, yeah. So if you multiply the numbers, you should get that constant, that third term, yeah. But if I add those two numbers, so I'm talking about the same numbers, if I add them, I should get that term in the middle, the coefficient of that term in the middle, which is 6. So that's the puzzle, yeah? So which two numbers multiply 8 and add up to 6? Now, if you don't know it, you could, for instance, what I call make a factor tree, and I call that a factor tree because this perhaps looks a little bit as a tree. 8, what times what is 8? Well, for instance, 1 times 8 is 8, yeah? 1 plus 8, is that 6? No, it's not. Well, then I move on. No worries. 2 times 4 is also 8. Yeah, I'm making my factor tree. And 2 plus 4 is 6. Fantastic. So my final answer then, if I have to factorize it, is x plus 2, x plus 4. Finished. And I can quickly expand that to check that. X squared, 4x plus 2x is 6x, and 2 times 4 is 8. Fantastic. All right, I'm going to give you another example, don't worry, of the normal factoring, if you like. Let's do, let me see, let me do a different one. No, let me do this one now, okay? And then in the next video I'll give you more examples. X squared plus 7x plus 12. Okay, so x squared plus 7x plus 12. Okay, the first question you ask yourself is there a common factor in all the terms? Yeah, though they have an x, but this one doesn't have an x. Yeah? So is there a common factor? No, there's not. The second question you always ask yourself, can I factorize it by grouping? Well, this one only has 3 terms, and for grouping I need 4, so no. The third question you ask yourself, is it normal factoring? And normal factoring is then 3 terms, yeah, 1, 2, 3, with an x squared, an x and a constant, just a number, and the x squared, the coefficient is 1. So it's just x squared. It's not 2x squared, it's not 5x squared or 3x squared. No, it's just x squared. And indeed, it is just x squared, so yes, it is normal factoring. All right. Because it's normal factoring, I can already put my sets of brackets there, yeah? And I can put an x here and an x there, because if I would expand it, I would do, first of all, x times x, and that is my x squared. Good. Two numbers, multiply 12, and if I add those two numbers, I should get 7. And then you start thinking, well, maybe some of you already know it, but some of you perhaps don't, so I excuse me, make a factor tree. 1 times 12 is 12. With a 1 and a 12, can I somehow add that to a 7? No. Move on. 2 times 6 is also 12. With a 2 and a 6, plussing that, can I turn that into a 7? No. 3 times 4 is 12. With a 3 and a 4, I can add that to a 7. Plus 3. Plus 4. Okay, check that quickly. X squared, 4x, plus 3x, 7x. 3 times 4 is 12, yeah? So that is my final answer. Normal factoring, where you have 3 terms and the coefficient of your x squared is 1. Yeah, so it's just x squared, nothing else. X plus 3, x plus 4. 2 numbers, multiply your last term, 12, the constant, and if you add them, it should be your middle term, that should be the coefficient of your x. And why should it be like that? I go to the first sheet of this video. Why? Because if you expand it, you always get 4x plus 2x, and then the sum of that is then the 6x, so the sum of those two numbers is the coefficient of your middle term. Okay, don't worry, it takes practice to really become confident and successful with this. So that's what you need to do. Go to my next video. I have example questions, yeah, because what happens when those signs are different, when they're negatives, both of them, or one of them is a negative and the other one is a positive. So I'll see you there.